So now again the next one is your transistor. So how this transistor is going to work, so which has just brought a lot of revolution in the technology. So that is nothing but your transistor. So it is a combination of two words, one is the transfer and register. So definitely there is a transfer of electron from one terminal towards the another terminal, and it offers some resistance. Yeah, so the resistance takes place from the input towards the output section. Yeah, so now again we have to see the various types of your, that is transistor also. So generally we just going to form by sandwiching one type of extrinsic semiconductor between other types of extrinsic semiconductor. So this is how we can show the NPN transistor. So that is a N type semiconductor, P type, and again N type. Yeah, so N type obviously we know that, so which is obviously emitter. We are just going to call that terminal you have to take, or you have to brought it out, so that we are going to call as a emitter. So which is going to emit the electron. So this emitter is again heavily doped. So this heavily doped means there are large number of free electrons are available. This base is lightly doped and its cross sectional area is also less. The collector, you can see that, which are going to collect all the electrons which has been emitted from this emitter side. Yeah, so that is what we can say about this NPN. So this direction or arrow, so this is how you can represent it. So this arrow indicates the direction of current actually, and then definitely according to the direction of your electrons, so which is opposite. Yeah, so this is how you can show its symbol for this your NPN transistor. Similarly, this is what we have shown the same case. Now what is the action of your NPN transistor? So just I shown you that this N consists of large number of free electrons. So you have to apply, you have to make the biasing for the same. So this is one we are going to call as a VEB. Yeah, so also this is sometimes called as a VBB. So making this as a positive, this as a negative. So this has to be negative and this one has to be positive. So all the electrons will get repelled, yeah, and they will just get enter into this base, which is thin and lightly doped. So large number of electrons which are approaching. So let's say 100 electrons are approaching. Holes means generally the vacancy for the electrons, so in which it is going to jump, but there are very few holes are available. So let's say there are only 3 holes are available. So out of 100, 3 that are 3 electrons will get combined with 3 holes. The remaining 97 will move towards that N type. Yeah, so that means the current will flow. Yeah, so that means the electron will flow in short across this from N to P, again from P to N, and then obviously it will just came out of this collector terminal, which constitute of your current. At the same time on this collector end, so it is a positive terminal, so which makes sure that the electron will get attracted. Yeah, so definitely, so the flow of current will continue over here also. So these are the two biasing, that means one is your VEB and VCB. Yeah, so that is how exactly it works over here. So this IE is equals to, yeah, now for this also how we are just going to write it down over here. So now generally this is your IE, so that is I will just, that is the emitter current, what we can say. Then again for the next case, so the next case definitely we can say for this particular case over here. So this is how I can just show that IE is equals to, that is obviously IC plus IB. So IC I can write it down as a collector current. Yeah, so this is how we can write it down. So IE is equals to IC plus IB. The base current is very less. Yeah, so yeah, IE is approximately equals to IC. So there is a slight difference between them. So this is again PNP transistor, which is exactly opposite that of your NPN. Yeah, so the opposite, so that means you have to connect it, this P terminal to the positive. Yeah, and this is again the direction of flow of current. So there is a flow of, that means the whole get transferred towards the right side. Yeah, and this is how the circuit, the current will flow through this circuit. So this is arrow indicates the direction of current also. Yeah, so we have to just sandwich that N type between these two P types again. So this is the same thing, emitter base collector. so there is a flow of current will occur. This arrow indicates the direction of your current. So the similar thing we have just discussed that for this case also. So now in case of your PNP transistor and that characteristics, that also we will see over here. So to measure the characteristics, so what we are going to do in case of characteristics common base. So there are three kinds of, you can say, configurations which are possible. One is nothing but your common base, one is your common emitter, and another is nothing but your common collector. So that we will now see. So in common base, the base is common between your input and output. So that is how we can show that. So the base is common over here. Yeah. So what you have to draw the characteristics for that. So this characteristics, the first one is the input characteristics. So that is a graph of your input current versus input voltage for the different value of your VCB. Yeah. So VCB, you have to make it as a constant, and now you have to just check the values for your input current. So let's say that is a IE, and then that is your input voltage VEB. Yeah. So now this is the graph that you will get, so which is almost a linear one. So for the different values, so let's say for VCB 0, then 10 volt, for 20 volt. So this is how the slope goes on increasing. Yeah. So there is a sharp increase in the value of your emitter current if I increase that voltage also. So this is called as the input characteristics. Then again output characteristics. So that is a graph of your output current versus your output voltage. So what you can say, again the VCB you have to increase for the different value, and at the same time you have to just measure the output current IC. So you can see that initially the value goes on increasing, but after that the value just gets saturates. That means even if you increase the value of your VCB, that doesn't result into the increase of your emitter current, because the number of electrons which has been emitted from that, obviously it is a emitter, is a fixed. Yeah. So even if you change the potential from the other end, it doesn't increase in the value of your emitter current. So that is how it gets saturates, and this is the graph looks like the IC versus VCB. At the beginning it get increased, but after that it gets saturates. So that is for the output characteristics for fixed value of your input current. So similar to that, so in common emitter, so the one was common base, this is common emitter, so which is mostly used in most of the application for your, obviously you can say that amplification purpose of you. Yeah. So where I'm just saying that again the input characteristics, the emitter is common between input and output. So that is again you have to observe that your input characteristics, that is a graph of IB versus VBE for different value of your VCB. So this is how the input characteristics you will get. Yeah. So to measure that IB, you have to just connect that ammeter, and at the same time to measure that your VBE, just change that VBE, and according to that obviously just measure the value of IB. So this is the graph that you will get keeping the VCB constant. Now similar, that is for your output characteristics, graph of IC versus VCE, that IC is the collector current, VCE obviously that is a collector and emitter voltage for the different value of your IB. Yeah. So this is all what we can say for the different value of, so this is the different value of IB which you have to just put it. Yeah. And according to that you will get the different values for the same. Yeah. Now the NPN transistor as a common base. Yeah. So this is how we can just use that NPN transistor as a common base, the different terminals which are connected. Yeah. So the one which we have shown already. Yeah. So this is how the electron that current flows, and this the circuit completes. Yeah. And you will get definitely, yeah. So this is how you will get a modify, that is a amplified signal. Yeah. So you will get a amplified signal at the output terminal whose voltage is greater. So this is what we can call as a common base. Yeah. So that common base we are using as a amplifier. So you can say that IC is equals to beta IB, the value of current gets amplified by some amount. So similar to that, so this is the same thing how we can show. Yes, so this is how we can show that input signal and your output amplify signal for this case. Now how exactly? Yeah, so this obviously input section is forward bias and output section is reverse bias. So after that we will see IE is equals to IB plus IC, and that ICRL is the potential drop. So then by Kirchhoff's law, obviously you can say that just apply that law, so which gives you VCB minus ECB. Yeah, so this is also I can write it down, VCB minus that is a ECB minus ICRL. Yeah, then again, so that is how you will get the input and output voltage. So what is the phase relation between input and output? Yeah, so if you say that, yes, so definitely you can say that output signal is a positive for positive input signal. So the phase difference is 0, they are in the same phase. That is what we can call over here. Yeah, so the similarly for negative cycle also they are in the same phase. So this PNP transistor that already we have seen as a common base amplifier. Yeah, so this is how we are just going to use that as a common amplifier. Yeah, now again, so similar to that also, so which we have just proved that. So what is the gains? What is the gain in the common base amplifier? So that alpha is equals to IC upon IE, and alpha DC is there and as well as alpha AC is there for DC signal as well as for AC signal also. So that is IC upon IE, that is called as a alpha, that is a current amplification factor. Yeah, or that is a current gain, by how much your output current has been increased with respect to the input. So that is the current amplification factor. Similarly DC current gain, just I said that there are two, and AC current gain. So this is the same thing which we have written over here, keeping this VCB constant, the change in the value of your collector current with respect to change in the emitter current. So what is AC voltage gain? So obviously that is the change in the output voltage upon change in the input voltage. So output voltage is change in the current into resistance, change in the current input current into input resistance. Yeah, so this is how we can just write it down. This IC upon IE is alpha, and this one we can say that definitely that is a resistance. Yeah, so this is also we can just write it down, that is a gain in the common base amplifier. So this is again the power gain. So you can find the power, that is a P naught upon Pi also. Yeah, so similarly you can find that the ratio of your power also for this particular case.